Section 1.3. In section 1.3, we are going to work on midpoints of segments that are in a coordinate plane. And we are also going to work on finding the lengths of segments that are in the coordinate plane. I'd like you to try these two warm-up questions and see if you can solve them, set up the correct equation and solve them, and then we'll talk about them. So the first question uses the segment addition postulate, which means that WT plus TZ would equal the entire segment WZ. So we just set the two expressions equal to each other, or add the two expressions and set it equal to the total of 161. So you can see that we get 56 inches for WT and 105 inches for TZ. In the second example, T is the midpoint, and the midpoint of the segment is the midway point. Now, we might not have really talked about that yet, but it kind of explains itself. Midpoint is the midway point. It's the halfway point. So we take the two expressions and set them equal to each other because each piece of this segment will be the same length. So MT will be the same as TS. So we set the two expressions equal to each other and solve for x. And then we simply plug it back in, and we can see that we do get a fraction for x, but when we plug it back in, we can either give our answer as a fraction or a decimal. So 37 units or 12.3 repeating inches. So our learning targets are, we are going to find the coordinates of the midpoint of a segment in a coordinate plane, and also we're going to use the midpoint and one endpoint to find the other coordinate. And then we're also going to find the length of the segment using the distance formula. So here's some terminology for section 1.3 and some notes. So midpoint is the point that divides a segment into two congruent segments. So again, just like I talked about a few minutes ago, M being the midpoint means that AM is the same length as MB. So M is the midpoint of AB. And we can tell that even if we didn't have those words because of these markings right here, these tick marks that we have. So what that means, since AM is equal to MB, then the segment AM is congruent to the segment MB. The second thing we're looking at here is a segment bisector, and that's really just a segment that goes through the midpoint. So a line that intersects a segment at its midpoint and cuts the segment in half into two equal pieces is a segment bisector. So L is the segment bisector of AB. So let's try a few examples here. We have line L bisects DF. So what that tells us is that DE is the same length as EF. And so if we know that DF right here is 11.6 inches, then all we need to do, it tells us that 11.6 is DE, so that means EF is 11.6. So then how long is DF? DF is 11.6 plus 11.6, which would give us the length of DF, or the distance between those points, as 23.2 inches. We're going to use the same picture, but we're going to have different information. Now it's telling us that EF right here, to find EF right here, so we're going to find this piece of the segment if we know that DF, the whole thing from here to here, is 30.4. So now we're going to take 30.4 and divide it by 2. And so now we know that EF is equal to 15.2 centimeters. Remember to include units on your labels when you're talking about length. So now we don't have a picture, so it's always helpful to draw one. It says line XY bisects WZ at point X. So see if you can draw that picture. So first I'm going to draw WZ, that's the segment WZ, and a line is intersecting it at point X, and it tells you specifically that it bisects it. So it's going to cut it in half. So here's our line right here, and it's line X, Y, and it bisects it at point X. So really, this point right here should actually be labeled right here as my X. And so now I know that these two pieces are the same. And we want to find XZ. So we want to find XZ, that part of the segment, if we know that WZ is 6 2/3. And you could probably do this in your head or on your calculator, but you're going to take 6 2/3 and you're going to divide it by 2. And just a note, when you are using a graphing calculator, you need to take this fraction and turn it into an improper fraction. So 6 times 3 is 18 plus 2. That gives you 20/3. And you need to use parentheses on your graphing calculator. So you would enter it as parenthesis 20 divided by 3, parenthesis, and then you divide it by 2. And that's actually going to give you a decimal, 3.3 repeating. So if you go to your calculator, there is a math button. And once you hit the math button, you can find from math button, the first one is an arrow to go to a fraction to decimal. So when you do that, it's going to change it from a fraction to a decimal, or a decimal to a fraction. We want to, in this case, change it into a fraction. So then we would hit that arrow right there, and that would give us our 3 1/3. If it doesn't specify, we could use either answer here in feet. So that is our length of XZ is 3 1/3 feet. Usually if the problem starts with fractions, we keep it with fractions. Next problem, S is the midpoint of RT. So again, S is the midpoint. That means these two pieces are the same length. So write an equation. Now we just have, instead of just plain old numbers, we have expressions. So 5x minus 2 is going to equal 3x plus 8. Now, don't be confused with, you have to understand if you're doing midpoint or segment addition, you're going to set up your equations slightly differently. But this would give you 2x equals 10, which would give us x equals 5. So now to find our S, I'm going to plug in 5. So I'd have 5 times my x value of 5 minus 2, which is going to give me 23 units. And then I know the other piece is already 23, so this is 23, and this is 23. So now I'm trying to find RT. Make sure you're trying to find the other question that's asked. So now I'm finding this whole segment right here. And so RT is just going to equal 23 plus 23, which is 46 units. Now, what do we do when we have a coordinate plane and we need to find the midpoint? If we're on a number line, we can just basically, if we were finding the midpoint of this segment on the number line right here, we could just take the average of those two numbers. And if we are doing it for this, between these two y values, we can just take the average and add them up, divide by 2, and that will give us the midpoint. That finds us the middle. Okay, so when we're talking about in a coordinate plane, what's going to happen is to find this midpoint right here, we're just going to take the average of the x values to find the x value of the midpoint, and take the average of the y's to find the y value of the midpoint. So the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2, and that will give us the midpoint of any segment in the coordinate plane. So if we try this one, we really don't even need to plot the ordered pairs, but sometimes it's helpful to make sure we didn't make a mistake in our work. So -3, 1, 2, 3, 4, 5, 6, that's right here. So that's point P. And Q is 7, 1, 2, 3, 4, 5, 6, 7, negative 2. Okay, and we want to find that midpoint. And so these are our ordered pairs we're going to use. And again, we really wouldn't even have to plot those points. So now, to find the midpoint, what I'm going to do is take the average of the x's. So I'm going to take, if this is my first ordered pair, this is x1, y1. This is my second ordered pair, x2, y2. I could flip that around. It wouldn't matter. I'd get the same answer. So I'm going to take negative 3 plus 7 divided by 2. That's going to give me the x value of my midpoint. And then I'm going to take 6 plus negative 2 divided by 2. That's going to give me the y value of my midpoint. So now I get 4 over 2, and I get 3 over 2. Oh, sorry, no, I don't get 3 over 2. I get another 4 over 2. 6 plus negative 2 is 4 over 2. So our midpoint of this segment is 2, 2. So it's really not too difficult, and I'm sure that you can handle it. So let's try a harder one. This one says the midpoint of AB is 5, 8. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So this is my midpoint right there. One of the endpoints, A, is 2, negative 3. So 2, negative 3. So what I want to know is where is point B? And it's even off my graph here, but I'm going to try to find it. So I'm going to take that same midpoint formula and I'm going to use it in a slightly different way. So basically what I know is that when I take 2, this is my x1, this is my y1, I'm trying to find my x2, y2 up here. So when I take that x value of 2 and I add it to the other x value and divide it by 2, that has to give me my midpoint x of 5. And same thing with the y's. When I take the negative 3 and add it to the other y value and divide it by 2 or take the average, that has to give me my midpoint of 8 right there. So now I just need to find out what they are, and I bet some of you could probably do these pieces in your head and just figure it out, but we can actually just set up the equation. We can take this and set 2 plus x divided by 2 plus x divided by 2 and set it equal to 5, and that will give us our x value. So the first thing you're going to do to solve this is you're going to multiply each side of the equation by 2. You have divide by 2, you're going to multiply by 2. That's going to give you 2 plus x is equal to 10. And now when you subtract 2, you're going to get x equals 8. So way up here, my x value is 8 something. Now let's do the same thing for the y values. So I'm going to take this and find what the y value would be. So when I take negative 3 and add the other y value and divide it by 2 to take the average, I know that the value equals 8 because this is the y value. So now again, I'm going to multiply each side by 2, and that's going to give me negative 3 plus y equals 16. Now I get negative 3, I'm going to add 3 to each side, and so my y value is 19. So my other ordered pair B is at 8, 19, and that is with that being my midpoint right here, and A being my other endpoint. So now I can actually make this segment, and there is my segment. So let's move on to the distance formula. And the distance formula is really based on the Pythagorean theorem. If we want to find the length of this segment, okay, we can't just measure it. It's in a coordinate plane. But this forms a right triangle right here. So if we can find this length right here, like our A, and square it, and we can find this length right here, that would be our B, and square it, we know that that will equal our C, or our value squared. So again, how do we find that value of A? Well, it's really just finding the difference between these two x values. So you're going to, just like the ruler postulate, you're going to take the difference between those x values to get your a value. And that's what this part is right here. Taking that difference and then squaring it. And that is what's giving you your a value squared. Okay, then you do the same thing to find your b. You take the difference in those y values. That's what this is. And that is what's giving you your b value. When you take the difference in the y values, that gives you your b value. You square it. And that is equal to the length of AB squared. So now when I want to find AB, what I need to do is take the square root. I need to take the square root of c squared and the square root of all of this. So that's what gives me my c value, which is my AB, is equal to the square root of a squared plus b squared. So it's really just the Pythagorean theorem. But sometimes it is a little faster and more convenient to actually use the formula given. So we have this distance formula right here. The length of AB, or the distance between the points, is equal to the square root of the difference in the x's squared plus the difference in the y squared. So let's try one of these, and then you can try the other example on your own. I'll work out one, and you can work out the other one and check out the notes. So if we just do this, I'll do this first one with you. This is our x1, y1. This is our x2, y2. And we're going to take and find jk. We're going to find the length of that by taking the difference in the x values squared. So I'm going to take -2 minus 1 squared plus the difference in the y values squared. So I'm going to take 4 minus 3 squared. So now I'm going to take -2 minus 1 more. That gives me -3 squared. Now don't forget you need parentheses around that -3 because we know -3 times -3 is going to be a positive 9. And then we're going to add that to 4 minus 3, which is 1 squared. So now we have the square root of 9 plus 1, which is the square root of 10. And actually, if you enter everything in your calculator with those parentheses around, it will actually just calculate it in one step. But I thought I'd work it out for you. And that gives you approximately 3.16 units. It wanted it to the nearest tenth, so we'll go 3.2 units. And that is our answer right there. So you try the next one. And if you've calculated it correctly, you would get that AB is equal to the square root of 128, which is approximately 13.3 units. And you can check the notes if you got it wrong to see what mistake you made. This says find the length of the segment, round your answer to the nearest hundredth. Same thing. So I'm going to let you work that one out. Again, check the notes for the answer. But let's move on to this. It says the endpoints of two segments are given. Find each segment length and tell whether the segments are congruent. Well, if the lengths are the same, then the segments are congruent. So we're going to find the length of each one. So again, to find the length of AB, or the distance between the 2 points, I'm going to take the difference in the x's. So 2 minus 0 squared plus the difference in the y's, 6 minus 3 squared. And so that equals the square root of 2 squared plus the 6 minus 3, 3 squared. So this is the square root of 8 units. I really don't even need to get a decimal, because if I don't get the square root of 8, they won't be the same exact length. So let's do the second one. Let's find out what CD is. So we have to take the difference in the x's again, -1 minus 1 squared plus 0 minus 3 squared. And that gives us a square root of -2 squared plus -3 squared. So that's going to give us the 4 plus 9. It's going to give us the square root of 13 units. So what we can say then is the segments are not congruent. So we can say that segment AB is not congruent to segment CD. And that's the end of this lesson.